डियर स्टूडेंट्स, इस वीडियो में हम लोग कुछ डिफरेंट कॉम्पिटिशन्स में जो सॉल्यूशंस के क्वेश्चंस पूछे गए हैं उनको सॉल्व करेंगे. तो लेट्स सी द फर्स्ट क्वेश्चन हियर. 18th question, an example of colligative property is, and you have been given the four options: freezing point, vapor pressure, boiling point and osmotic pressure. And this question has been asked in BHU 1990. So a colligative property, as we have already dealt with, is the only osmotic pressure here. So answer number 18th will be D. So here I will write answer 18 as D. Okay, that is osmotic pressure. Next question is question number 19, which has been asked in CEE Kurukshetra 1991. That is, what is the molality of the solution of a certain solute in a solvent if there is a freezing point depression of 0.184 degrees Celsius and if the freezing point constant is 18.4 degrees Celsius per molar. So here we will apply the formula, that is depression in freezing point. Answer number 19 is depression in freezing point is equal to Kf, that is depression constant, into molality that we have read. So here you have to find the molality of the solution, that is M. So the M will be equal to del Tf divided by Kf. So here the depression in the freezing point is 0.184 and the freezing point constant is 18.4. So let's solve it out here. So we will get here 1 upon 100, that will be equal to 0.01. So that is answer number A. So here the answer will be 0.01, that is answer number A. Next question is, as in IIT 1993, this is question number 21. The vapor pressure of a solution of a 5 gram of a non-electrolyte in 100 gram of water at a particular temperature is 2985 Newton per meter square. The vapor pressure of pure solvent is 3000 Newton meter per square and the molecular weight of the solute, you have to find it out. So here let's see how we will solve this question. Answer number 21. We will put the formula as the relative lowering on vapor pressure, that is P naught minus P upon P naught, is equal to the mole fraction of solute, that is weight of solute divided by molar mass upon weight of solvent divided by molar mass of the solvent. So here the vapor pressure of the pure water is given as 3000 minus 2985, that is the pressure of the vapor pressure of the solution has been given, and again P naught is 3000. Weight of solute has been given as 5 gram. So here we'll put 5. You have to find the molar mass of the solute, so let it be X. The weight of the water is given 100 divided by water molar mass is 18, and let's now solve it. Here we will get 15 divided by 3000 is equal to 5 by X into 18 by 100. So this is here 20, 15 to the 200, and X you will get 20X is equal to 3600. Cross multiply and X will be equal to 0 will get cancelled, and X will be 360 divided by 2, that is equal to 180. So here you can see the 180 is answer number A. So here the answer will be A. Next question is, the Van 't Hoff's factor for 0.1 m ideal solution is. So here the answer will be B1, because ideal solution neither undergo association nor dissociation, and if there is no association or dissociation, the Van 't Hoff's factor will always be 1, as I have already told you while solving the questions for Van 't Hoff's factor. So here the answer will be B, that is 1. So answer number 22 will be B, that is 1. Okay. Now the next question here is asked in AFMC 1997. A geotropic mixture of HCl and water has how many percentage of HCl? That is 20.2% HCl. Next question is, that is answer number D is here. So answer question number 24, answer is D. Question number 25. Which of the following 0.1 m aqueous solution will have the lowest freezing point? Now out of these four, you can see these two are non-ionizable compound because these are covalent compounds. And Ki, if you will ionize, you will get 2 ions, and which is exactly proportional to I, that is Van Hoff factor, so that is 2. And here you will get 2 aluminium ions and 3 sulfate ions, that is total 5 ions, which is again directly proportional to I. So the aqueous solution which have lowest and freezing point is directly proportional to I. So this will have the lowest freezing point, inversely proportional to the I. So it will have lowest freezing point, having maximum ions. So answer number 25 is A, because I for aluminium sulfate is 5 and for Ki it is, and for Ki it is 2 because it will give you 2 ions and it will give you 5 ions. Next question is asked in AIMS 1992. You have been given a 500 toothpaste sample and 2.2 gram fluoride concentration. What is the concentration of fluoride in terms of ppm? So let's solve this numerical. Question number 29. So answer 29 you will solve like this. That is 500 gram has 0.2 gram fluoride. And if you have to find in ppm, so 10 to the power 6 parts will contain how much fluoride? That is 0.2 into 10 to the power 6 divided by 500. So first remove this decimal, 3 will get cancelled. So now you will have 2000 divided by 5, so that will be equal to 400. So here the answer will be 400, that is C. Answer will be C. Next question is question number 30. You can see here question number 30. This was asked in AIMS 1997. Which is not affected by temperature? Normality involves volume, molarity involves volume, formality involves volume, but molality involves per kg of the solvent, and volume is affected by temperature. So answer will be D, because D does not involve volume and volume is not affected by temperature. Volume जो है temperature से, इसमें क्योंकि वेट है और बाकी में वॉल्यूम है, और वॉल्यूम टेम्परेचर से इफेक्ट होती है, जबकि वेट जो है वॉल्यूम से इफेक्ट, टेम्परेचर से इफेक्ट नहीं होता है, तो इसलिए यहाँ पे आंसर होगा डी. यू कैन सी अनदर क्वेश्चन दैट हैज बीन आस्क्ड इन ISC 2009. That is, the molecular weight of sodium chloride determined by measuring the osmotic pressure of its aqueous solution is double the value, half the theoretical value, same as theoretical union, 3 times the theoretical value. Now here you can see the molecular weight of sodium chloride. Sodium chloride dissociate to give you 2 ions. And answer number 31. Osmotic pressure is a colligative property which is inversely proportional to the molecular weight, as I have already told you. It is a colligative property and it is inversely proportional to the number of solute particles. Okay. So here the particles are 2 ions are forming. So molecular weight will be inversely proportional to this. So you will get the molar mass will become half of its original value. So here you will write the answer will be half the theoretical value. So answer number 31 will be C. Let's come to the next question that is been asked in Delhi College of Engineering in 1999. Freezing point of water is 0. At what temperature will 1 molar solution of NaCl freeze? Its FnCl is completely dissociated and molar depression constant is given 18.6. So here we will assume the formula. Answer number 34 here is, that is depression and freezing point, that is del TF is equal to I into the constant, depression constant, that is Kf into molality. So here del TF you have to find it out. I is 2 because 2 ions will be formed, into depression constant is given 18.6, into molality is given 1. So it will come out to be 12, 16, 17, 37.2. Now you have to find, let's assume here the freezing point is 0 degrees Celsius. So X 0 degree Celsius minus x. So here x will be equal to minus 37.2 degree Celsius. Students, I am getting 37.2 degrees Celsius, but here the option is given as 3.72 degrees Celsius because here the depression constant is given wrong. It should be 1.86, and if it is 1.86, then you will get minus 3.72 degrees Celsius. Okay, so I have calculated according to 18.6, but here it should be 1.86. There is a misprint here, and according to that, the answer will be A. That is, answer number 34 is A, minus 3.72 degree Celsius.